Hello friends, this is part 1 of question paper solution 2023 physics C1 paper mechanics, okay, of Dibrugarh University first sem BSc physics. So before we start, please subscribe the channel, hit the thumbs up button so that you get notified when new video will be uploaded. And if you like my videos, then please hit the thumbs up button as well and share with your friends. Inspire me to create new videos for you and help me to grow my channel. And if you want me to follow, you can follow me on Insta. This is my Insta ID, Lakhyajit 123. Right, so now let's start. So here is the first question. All frames of reference moving with constant velocity with respect to an inertial frame. Suppose this is an inertial frame, and so we have more frames. These are moving with constant velocities with respect to this frame. Then if these are moving with constant velocities, then these are also nothing but inertial frame of reference. We can say this is the first option. The first option is correct, and the remaining options are here on the other page, but here the first option is the correct answer. So answer is option 1. Right, now let's move on to the next question. Here you see, this is the next question. Which of the following relation between F and V is correct? So V is here potential energy, and we know that force is negative gradient of potential. So option this. So that is why the option is here also first one, option 1. So force is negative gradient of potential, that's V, right? So now here you see, next, if E is the kinetic energy, this is the kinetic energy, right, and of a body, then the moment of inertia of the body. So we know that moment of inertia and kinetic energy relation. Kinetic energy is equal to half I omega square. That is the relation, and here the kinetic energy is given E. So half I omega square. So moment of inertia I, that's gonna be equal to 2E by omega square. So which option is correct? 2E by omega square. That's option number 2. So option number 2 is the correct answer. Right. So answer is number 2 option is the correct answer. 2E by omega square. This is the moment of inertia of the body. So hope you have understood this. Now let's go to the next question. So here you see the relation between the angular momentum L and the torque tau is given by derivative of L dl by dt. Here you can say this gives torque, right? Then what is the condition for conservative angular momentum? So for a condition for conservation of angular momentum, so angular momentum will conserve when the torque is equal to 0, right? When the torque is equal to 0, then torque 0 means derivative of L with respect to T is 0, and we know that derivative of constant is 0, so ddt of constant is 0. So that's why from here this implies L is constant, right? So that means when this is equal to 0, then angular momentum is conserved. So when this is 0, then time derivative of L is also 0. So which option is correct? This number 3. So option number 3 is correct. So answer is 3. Right. This is the correct option, number 3. So next, the velocity of a particle executing simple harmonic is minimum at a point where the displacement is. Now let me clean these things. So now let me tell you one thing. Suppose we have this pendulum and it is swinging this way, right? That means it is executing simple harmonic motion. Then here you see, at the extreme points, we know that velocity is minimum, that is 0. Okay, and in that case the displacement is maximum, right? Then displacement is maximum. So here the correct option is option 2, right? So we can write the answer, that option 2, that is when the displacement is maximum, so this is the correct option, right? So now let's go to next page. So here is the next question. The amplitude of a simple harmonic oscillator is doubled, then the time period will remain same. Okay, so this is the fourth option, because now you see this time period doesn't depend on the amplitude. Okay, so hope you have understood this. So now cause of fictitious force, and that is option number 2, acceleration of the frame of reference compared to a non-accelerating frame. Okay, so this is the cause of fictitious force. So option 2 will be the correct option. Okay, now next question. What is the next question? Here you see, so Coriolis force acting on a particle of mass m, that is actually given by -2m omega cross Vr. That should be the formula. Here I think there is printing mistake, so this should be the formula, right? So now you see, next, S dash, a frame of reference moves along a positive direction. There is a frame of reference, this is S dash, and it is moving along x direction, positive x direction, with reference to a frame S. There is another frame S. With respect to this frame, this S dash is moving in x-axis, along x-axis. Okay, and a rod is placed along y-axis. Right, along y-axis a rod is placed, but as this is moving along x-axis, there will be no change in length along y-axis, right? So here, if the rod is observed from S frame, then it appears contract, elongated, unchanged, none of this above, so it's gonna be unchanged. So that's gonna be unchanged. So option 3 is the correct answer, right? And the last one, the last objective, last question, which is MCQ, last MCQ. Massless particle can have energy and momentum when the particle, that's very simple, moves with speed of light, right? That moves with speed of light. So we know that energy, which is equal, I think this equation, E is equal to mc square. This is mass, right? If mass is equal to 0, if an body is massless, then it's supposed to be 0, but actually this is not the complete equation. What is the complete equation, right? The complete equation is E square is equal to mc square whole square plus P into C whole square, right? So momentum, we know that m into v, but this is correct for only those particles which are moving much slower than light. Okay, so that's why if you see if you consider a massless particle, then though mass is 0, then if you cut it, then this is gonna be 0. Here we're gonna obtain E square is equal to pc whole square, and here we have got momentum as well as energy. So in this relation we have momentum as well as energy, and from this relation we can calculate momentum as well, right? Momentum, that's going to be E by C, okay, and energy is simply this, E is equal to P into C for massless particle. So hope you have understood this. So that is the correct answer. So in the next video we're going to start solving from question number 2. From question number 2 we're going to solve in the next part 2. So when it's going to be uploaded, that's going to appear at the end of this video. If it is not uploaded yet, then you can't find that video at the end. So when it will be uploaded, it's going to appear itself. So thank you for watching. See you in the next video.